Hello. So I put a lot of unicorns in my slides. If you know me, you know that's my thing. But I did it particularly there because it's quite hard. We will talk about mathematical theorems like the Cap Theorem, the PACELC theorems, and so on. So I tried to lighten it up with unicorns, and unicorns never disappointed me. So first, who am I? So Ilaria said, my name is Laetitia Avrot. I like my slides to be without any word. So if that's a problem for you, or if maybe the last slides are about architecture design and there might be a lot of things that can't be read so easily, you are welcome to go to my website, mydbnotebook.org, where you will find a conf talk tab, where you will have all the annotated, what I call the annotated slides. It's slides with bullet points, so that if you need more words to be able to follow, you will find them there. I also publish them on Twitter, on my account at L_Avrot. So, who am I? I'm an EDB field CTO. I'm also a PostgreSQL recognized contributor. And I'm the founder of Postgres Women, which is just a small group trying to bring more women into Postgres and make them who are already there more visible to everyone. So we will be talking about chasing unicorns. What that means is we will have an agenda with 3 points. The first one is data loss and downtime. Second one will be about the famous Cap Theorem and the less famous PACELC theorem. And the third one, I will try to show and display some typical architecture I designed for some customers. So it's real cases that I created for customers. So first, let's get straight on something. Zero data loss can't be reached. To quote Robert Haas, should the Death Star come and do to the Earth what it did to Alderaan, everyone will lose data. But normally, that shouldn't be a problem. So, no, you can't reach zero data loss. But I found out that for most humans, when they say zero, they don't mean zero. They mean something close to zero. But something close to zero can be for IT people, because I found out that IT people have the tendency to think like computers. So zero means zero. When I had some customers that said zero, it meant that they were allowed to lose 1 day of data. That's zero to them. So the first thing you have to understand is when someone says zero, you really need to explain that a mathematical zero is not possible, but a human zero is possible. About allowed failure time, so the same thing, should the Earth explode? I guess most of software will have some availability problem, but again, the humanity wouldn't care. So normally we talk of availability with a percentage. 100% of availability means 0 downtime, which is not reachable. I will say it several times so that it's printed in all your brains. 5 nines means that we can have less than, we can't afford to have more than 5 minutes of disruption per year. That's not so easy to reach. For 4 nines, it means 52 minutes per year, and 3 nines, it's a little less than 9 hours. For the record, Facebook this year won't reach 3 nines. And I had something interesting with the customer saying, I don't want 5 nines. What I want is 5 nines only during the daytime, because I don't care about the night. That was worse than trying to reach 5 nines, because it means that we can't allow more than 3 minutes of yearly availability disruption. And then you need to keep in mind that normally your database is not alone. There are a lot of things that running around, and everything can break. So these are the minimal layer you should have, but I guess that nowadays your architecture have more layers than that. So first you have the database that should rely on an OS and at least hardware. But I guess you will have a lot of layers between hardware and OS, and between OS and database. Maybe you have VMs, maybe you have other things. And then you will have the applications that will rely on network, and again, will rely on hardware and OS. And on top of that, you will have the client that will rely on another network, or maybe the same than the application. And sometimes this network is the internet, and internet can fail. So what I mean is, it's great to have a good availability percentage for your database, but if you don't have the same for all the other layers, it's not worth it. It will only cost money for nothing. So let's reach the Cap Theorem. The Cap Theorem says that when you're designing distributed web services, there are 3 properties that are desired: consistency, availability, and partition tolerance. Partition tolerance means network partition tolerance. And the theorem states that it's not possible to achieve all 3. Commonly, you will see this representation of the Cap Theorem. And I don't like it, actually. I will explain later why. But first, let's state what consistency means. Consistency means that each node will see the last committed version of the data. So eventually, consistency is not consistent. Availability, it's when the system will always answer something different than an error message, and a timeout is an error message. And the last one, which is a trickier part, network partitioning. The network will be allowed to lose arbitrarily many messages sent from one node to another without altering the system answers. So that's the trickier part, because we know that that's almost impossible to reach. But we can have systems that will take over when there's some network failure, but it won't be without without disrupting availability, because there will be a short period of time where you might get an error message, or with a problem with consistency. And we'll see later why. What I love with the Cap Theorem is I love picturing it as a rubber band. You have 3 wood stick: consistency, availability, and the third one is network partitioning. What you can do with the rubber band is putting it around 2 wood stick, but it's too short. You can't put it around the 3 wood stick, but you can bend it to be as close as you want from the third wood stick. That's how I explain the Cap Theorem. I'm sure you've already seen that RDBMS are consistency and availability compliant, but not compliant with network partitioning. That's something that's true and false. Let me explain. If you have only a standalone server, then yes, you can achieve consistency and availability. So in that case, that's CA. But if you have a synchronous streaming replication, then you can achieve more availability even during network partitioning, but you won't reach consistency. Meaning that there is a short time where you can query a standby and will get not the last committed data, which might be fine in your application, but you just need to know it. And the third case is when you have synchronous streaming replication, meaning the standby has to acknowledge the commit before it's actually committed on the primary, then you are neither consistent, because there's a very short time when the standby will have the data committed but not the primary node, but close enough. You have less availability, because should the standby fail, then your primary won't be able to write. But you're a little more resistant to network partitioning. And then it goes further with the PACELC theorem. This theorem, the first thing it states is just repeating the Cap theorem, so that's easy. In case of network partitioning in a distributed computer system, one has to choose between availability and consistency. That's exactly the Cap theorem. But else, even when the system is running normally in the absence of partitions, one has to choose between latency and consistency. So I will explain what latency is. Latency is the amount of time the system needs to answer when it's smaller than a request timeout. As I said, a request timeout is considered as an availability disruption. So it means that after you've made your choice between having a system more consistent and more available, or a system, after having done that choice, you will have another one where you will have to choose between the consistency and the lag, basically. That's what it means. This leads me to what I call the blueprints, could be called the examples of architectures I designed for customers depending on their constraints, because that's what's important. You need to take care of the constraints to find out what is appropriate. I have a lot of customers that say, I want the best you have so that it can do anything. I say, but there is no best. The best is what fits your needs. That's a little difficult for some to understand, but it's not because you have the most available system that it will actually fit the application needs. And it will be more expensive. Right before that, I'd like to explain a little vocabulary. I will use the B analogy for my database servers. I don't use the master slave terminology, as we have banned it from the Postgres world for two main reasons. First reason, it's offensive. Second reason, it's not a good analogy at all, actually. When master died, we didn't put a slave as a new master. We just took another master. So in pedagogy, when an analogy is not good, we just change it. That's what we did. And the bee analogy works like in a hive, you have three types of bees. You have the queen, which will be our primary database. You have princesses. A princess's role is only to be there and take over the queen should the queen fail. So that's standbys that are not used to serve read queries. And then you have workers. Workers work, and so that's the standbys that serve read queries. I love it because that's a way to show that you can't have a database server that will be at the same time serving read queries and be a good fit at any time to fail over to. Because in our imaginary, we can't imagine a situation where a worker will be a good princess or where a princess would be a good worker. That's not something that fit together. So, about when you drag, sorry, I wrote the RPO. Does everyone know what RPO and RTO is, or do I need to explain them? Yeah, okay. So, recovery point objective, when you can afford to lose more than 15 minutes of data, having a physical backup and wall archiving should be enough to reach that point. When you can lose more than 1 minute, but not less, then you might need an asynchronous presence. Sorry, the word princess is in French, not in English, but it's close enough. So in that case, so an asynchronous princess, considering the princess is in the same network and same data centers than the queen. So normally in an average network, the lag should be between 200 milliseconds if you have enough resources on the princess to apply and replace the walls. So your lag between the queen and the princess needs to be monitored seriously, just to be sure you can achieve your RPO. And it's not something you have to monitor once. It needs to be constantly monitored because your database will change, your database workload will change, and so you need to be sure that you will at all times be able to reach your recovery point objective. When you want to reduce the data loss around 200 milliseconds, as I said, that's typically the lag between a queen and a princess, then you can rely on a synchronous princess. But you see that under parentheses, I added an asynchronous princess. I have never seen a setup with only a synchronous princess. Because the problem is, when I mean an asynchronous princess, it's a second synchronous princess with a quorum of 1. Meaning that at one time you will have one synchronous princess and the other one will be asynchronous, but should one princess fail, the other one will be there, because you don't want to have right description on your primary node because a princess failed. And then again, recovery point objective of 0 is not possible. About recovery time objective, if you can allow 24 hours, oh, sorry, that's totally in French, actually. Translation, yeah, lost in translation. Okay, so when you can afford more than 24 hours, but it will depend on the, that's what the French says, it will depend on the time you need to restore your backup. And should you have a big database, this time might become really important. Then a physical backup with wall archiving should be enough. But again, you will need to monitor your restoring time. And you will do that by testing your backup, which is a good thing because you should at all time test your backups so you're fine. If you can't achieve, if you can't afford more than 30 minutes of disruption, then you will add a princess with manual failover, considering you have a team that can perform the failover in less than 30 minutes. 30 minutes will be counting from the first disruption, so it means that you need the monitoring team to find out that's a problem. to reach out to the database team and the database team to connect. You know that the VPN will be failing because it's 2 a.m. and you don't know why the VPN is always failing when it's 2 a.m. And then you need to bring the VPN back. And then the database team will be able to connect and to perform the failover. That's an average of 30 minutes if you have a good team. It can be a lot more with a not so good and experienced team. If you can't afford more than 5 minutes of disruption, then I strongly suggest to go to automatic failover so that the automatic failover will still take some time because we don't want to fail over should any network small disruption happen. So what most automatic failover tools do is they check for several seconds to find out if it's just a small disruption of 30 seconds, for example. And if it can't reconnect, it will retry several times. So that's why I put 5 minutes. Of course, there are settings to put it lower, but the problem is once you have failover, you will have to rebuild your old queen as a princess, and you can't convert a queen into a princess. That's not possible. That's French too. If you can't afford more than 1 minute or 30 seconds of high availability of disruption, then I strongly suggest looking at what we call multi-queen. It's a setup where you can write in several databases at the same time. But keep in mind that your application needs to be aware of that and needs to be compliant with such a technology. And again, should you want to reach zero disruption, that's not possible. So that's when we reach the part where it might be tiny and you might want to use your laptop to find to read the architecture design I wrote because the slides are too tiny for me. But I will go in detail through the different parts. So that's a standard architecture I used by a customer. It fits a lot of budget and a lot of use cases. It can work with 1 or 2 data centers. Here it's only 1. Most of the time you will have an RTO around 30 minutes because it's a manual failover. And most of the time, you will have an RPO of 200 milliseconds because there's an asynchronous process. And just note that my hosts are not called queen and princess. They're called blue and green because it's a bad human habit to decide which database server should be the queen and which one should be the princess. Your architecture should be able to work the same way with whatever server is picked as the queen. So first, the database server. So you have the application and a connection pooler. Most of the time, you need a connection pooler with Postgres due to how it was designed. And I suggest strongly to use PGConf, but there are others. And then, so the application goes through PGConf into the database server, which is the queen. And then, with asynchronous streaming replication, data changes are sent to the princess. And then we add other tools to the mix. So you have a backup tool here, and you see that I have another database server on my backup and tools host. Why? Because you will test your backup. That's something you should do, and we know that when you have a disaster in production and you need your backup, it's not a comfortable situation, but when your backup is corrupted, that's worse. So you might want to check your backup. And then what I like to do here, it's a configuration file versioning. That's a folder here. I tell my customers to put their configuration files of Postgres inside a Git and to explain on the commit messages why they change a setting. Normally they don't understand why, but some experienced people understand. I got a guy who thanked me 2 years after because he couldn't find out why the setting was changed. And then I added a monitoring with a monitoring tool with a monitoring database and monitoring agents on the databases server. So this works very fine. It's not the best available architecture. It's not the best reduced data loss architecture, but for most of my customers, that's enough. And I like the KISS principle. KISS is for keeping stupid and simple. And when it's stupid and simple, the probability that it fails lower down. Then I had this weird customer who wanted to have fast reads. And the reading needed, it was medical grade data used in hospitals, meaning that when a patient is in an emergency, they'd like to have the patient's file really quickly so that they can see if he's allergic to any medication, something like that. That was a life or death situation, actually. So they wanted to have very fast reads. And they wanted to have also a great read availability. And they wanted to lower down the data loss risk, of course. So the first thing we did is design a setup with the application on the top. They were using JDBC and the connection puller inside JDBC. So what they used, actually, was 2 data sources in JDBC so that they could redirect the read queries into the workers, and they could redirect the write queries into the queen. And they had also third-party software, and they could change them so that the read and write queries for this software would end up directly in the queen. To reduce the risk of disruption, we added a princess. And we had several workers, and they were able to spin up new workers when they saw that reading was taking too much time. They could add new servers. Then we just added a backup tool, and we also added a cold standby. A cold standby is a standby that is not open. So it's when you restore your backup, and then you close the database. Well, you restore your backup, you perform the recovery, and then you close you stop the Postgres instance. And again, we had the folder with the configuration file. The backups were tested every day. And then for high availability, we added a second data center to the mix. So it's the exact same architecture, but with a second data center, but you can't have 2 queens. So we had 2 princesses. And what we did is, with the 3 princesses, we created a quorum of 1, so that with a synchronous replication to reduce the risk of data loss, meaning that now we have 5 copies of the data. And there are several scenarios of data loss, but they were in several disk storage, and the backup was stored in another facility too. So we had several copies of the backups with the archived role, and normally we were more safe. Of course, again, should the Earth explode, everything will be lost, but that's not the problem here. And so they had the backup on the blue data center, again, the blue-green denomination, because I want the architecture to be able to work whatever data center is the primary one. And we did another backup setup on the data center green. And we added other REST. Other REST mean monitoring server with monitoring agents on all the databases server. And we added also a management of all this data because we knew they will end up with a lot of data, but we found out that having data on dead people can be delayed. We can wait a little more to have data on someone who's dead because there's not so much you can do when somebody is dead. So we decided to have online archiving for dead people, and offline archiving, it's just data files, it's just files that could be imported on demand for people dead for more than 10 years. So that we can keep the database size relatively small. It's not small, but it's manageable. And that's what I call an acceptable trade-off. And the last one I did, it was a bank, and they wanted to have a high availability setup. They wanted to reach 5 nines, which, as I said, is very, very difficult. And yeah, there is no guarantee you can achieve 5 nines because should all your data centers fail, you won't reach it. And they had a lot of rights because normally bank's workload is transactional. So first, we added BDR. BDR is for bidirectional replication. It's a closed source, but it allows to perform multi-queen setup. We have 4 queens here. And we'll see later that actually only 2 are in use, and the other one are called, in our terminology, shadow queens, and they are leader queens. We also added a witness in a 3rd data center because we need at some point to figure out what's going on the network level. Should there be a network disruption between both data centers? So the witness node will ensure majority for any consensus to be that needs to be done. And then we added a logical replication, a logical princess, to have 2 other copies of the data. Why did we do that? If we add another set of 2 queens, there will be a lot more network communication because each BDR node needs to communicate with all the others. So with 6 nodes, actually that's factorial 6, so that's a great number of communications for each change. So we added a logical standby because that way we have another copy ready of the data and we can promote it as a queen should one of the queen fail. It's easier and quicker than having to reset a new queen from scratch. So we do that for customers who have a lot of data. Of course, we added PGBuncer as a connection pooler because transactional workloads typically use a lot of connections. And as I said, each connection is a fork of the postmaster process, so it can take a huge, a lot of resources on the OS level. Actually, that was an argument I had with the customers. They were having 10,000 connections to Postgres, and they were saying that Postgres was slow, and they were constantly creating new connections. And I said, it's not Postgres that's slow, it's Linux, because it can't fork fast enough due to resource consumption. And we also added hproxy to redirect the application queries to the right leader queen, so that we'll end up with always at the leader queen, and should a failover happen, we will end up in the former shadow queen. And then we just have to add the backups. So here it's not written, but of course backups needs to be tested again. And the physical backups happen on the leader queen. It shouldn't be a problem as we have a duplicate setup, so it shouldn't be a problem with the current workload. So I'm sorry, I'm a little early, but to sum up, you need to keep in mind that your database is not the only element that can fail, and you need to dimension your architecture for the database, but also for all the other layers. Because it's great to have a database working under Windows server, an old version of Windows Server, but I'm not sure it's that reliable. The second thing I'd like to say to my customer is that they're not Google. So they don't need the same things as Google. And it's not because Google goes that way that it's something that fits their needs. And the last thing, which is the most complicated, is we have, each time that we go to design an architecture, we have to figure out what are the RPO and the RTO. And that's the most difficult thing, because people want everything. People want zero data loss. People want 100% of availability. And with the one to say that's not possible. But as I said, we have to discuss with the customer to find out what they mean by zero data loss or 100% of availability. I had a customer who wanted high availability, and I found out later that for the last upgrade of their software, they were able to disrupt their service for 3 days. So that's not high availability to me. It was to them. So you need to really figure out what it means. I had also another funny story. I had this customer who migrated from Oracle to Postgres. And he said, I'm not so sure about Postgres. I know that Oracle is stable, but I'm not so sure about Postgres. So I will add a standby just to have a failover should I need to. 1 year after, he came back and said, OK, so Postgres is really, really stable. He experienced no failure. And he said, this standby cost me more than a disruption. So he took off the standby from his architecture. And that's totally understandable. And that's what I mean when I mean doing KISS architecture. Keep it simple and stupid. If you need only a standalone, just add only a standalone. I'd like to finish with this quote from my friend Gulshin. We had a discussion about a customer who wanted zero data loss and 5 nines, and she said unicorns are more real than zero data loss and 5 nines availability. That's how I came up with this conf tool, actually, and I thank Gulshin for that. Do you have any question? Yes.
So in one of the slides, unless I misunderstood, sorry, I was going to do this. You said that it wasn't possible to convert a queen into a princess.
Yes.
But, I mean, with the restore PG rewind.
Yes. It's just not something you want to automate.
Right, understood.
Because when there's a failure, you want to understand what happened so that it can't happen again.
So in that case, which one do you prefer to use, PG rewind or a restore from backup?
Yeah. No, you can use PG rewind, but
Okay.
it needs to be done by a human.
Right.
You don't want to create a script to automate that. That's one of my nightmare when customers say, "Oh, we can automate it." No, you can't.
Okay. Fair enough. And then second is for you talked about automated failover, but you didn't give any architectural examples of it because you kind of went straight to BDR. Any thoughts on that, like the time to failover, tools to use, things
Actually,
like that?
the time to failover is not a problem, as you have two queens.
No, I meant not using BDR, doing high availability with automated failover. So your
Yes.
RTO is less than 1. You need automated failover.
Yeah.
Just some thoughts on that, because you didn't give an architectural example of that.
Yeah. You can tweak the first architecture to add automatic failover and perform it very simply and have the less than 5 minutes disruption.
And for that, you generally be using Patroni these days?
I was thinking of EFM or Rep MGR, but Partitioning can do it too.
Okay.
Maybe you have a story about architecture design you'd like to share, or production failure due to bad architecture, or anything that failed you and that was not the database? Yeah, Tom?
Your last architecture, where you had 2 PG bouncers.
Yes.
In the case where one fails, how does the application go to the second one?
Actually, there's a script that will use a resume when you will have access to the former leader queen, shadow queen, sorry.
I'm sorry, you had the the connection pooler in front of the queen, right?
Yes.
I'm not, what's the term? And then if the connection pooler fails, do you have a script in that?
You know that you can create several PG bouncer on the same host using reuse port. That's what I advise.
Got it. Great.
But yes, PG bouncer can fail too, as any layer in the architecture. So, yeah.
You mentioned how in your one architecture that Linux was kind of a bottleneck. I'm wondering if you could elaborate a little bit more on that.
Okay, so when you're constantly creating new processes, it takes, each time you create a process, it takes a little resources, a little CPU, a little memory, not a lot. But if you're creating 10,000 connections per second, it means you will fork 10,000 processes per second. And that's how these little tiny resources, by adding up, will become a problem.
Okay, thank you.
So I think it's a good place to wrap it up. I'm available for any private question if you have them.